Okay, we are going to just work some examples out for us here. Okay, this is going to kind of give you guys step-by-step stuff of what you need to do. Like I said, I know that this is confusing here, but the more examples that you guys continue to practice over and over again, the better you guys will become at this. Okay, so starting out, we've got a function 3x to the fourth minus 2x cubed plus 3x minus 5. Okay, this is a degree 4 equation. Okay, so I have 4 in all of my spots there. Okay, now find my v positive. How many variations do I have? 1, 2, 3. So we have 3 variations for my 3 positive. And that means there is 3 or 1 positive real zeros. Okay? Then I'm going to go through. Now remember, we have to plug in an f of negative x. And I kind of showed you guys a little trick here. If they have even exponents, their signs don't change. If they have odd exponents, their signs will change. Okay? So this becomes 3x to the fourth, odd, so that will change to a positive 2x cubed. Okay? Odd, so that will change to a negative 3x minus 5. So how many variations do I have for v negative? Positive, 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 negative, negative, negative. So I only have 1. And that means that we have 1 negative real zero. Okay? I know for a fact that I have 1 negative real zero. Okay, so we're going to start filling in. I could have 3 positive real zeros. How many negatives could I have? 1 is the only option. So I could have 3 and 1. If I had 3 and 1, how many imaginaries would I have? Well, 3 plus 1 is 4, so I would need a plus 0 because 4 is the maximum. 3 plus 1 plus 0 gives me my 4. Okay, next option. I can't do 3 again, okay, because 3 and 1 is the only possibility. So the next possibility would be 1 and 1. So I could go 1 positive, 1 negative. How many complex would I need to get to 4? Well, 1 plus 1 is 2, so I would need another 2. Okay? So I hope as you guys start doing these, you kind of start to see the pattern and start to feel more comfortable with it. Let's do another one here. If you're feeling kind of comfortable, go ahead and try and pause the video and do it on your own. Okay? If not, that's okay as well. Okay, so this is going to be a degree 3. Okay, so the first thing we need to find is our v positive. Okay, so there is 1, 2. So our v positive is 2. So that would be 2 or 0. Okay, positive zeros. Okay, next, I need to plug in that f of negative x. Okay, odd exponents, it's going to change the sign for. Evens, it is not. Odd, it changes. At 14, it's not possible for it to change. Okay, so on this one here, how many variations do I have for my v negative? Negative, 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 positive. So there's 1. And then positive, positive. So my v negative is just 1. So again, I only have one option. I have 1 negative 0. Okay. If you want to figure out how many rows you need to have in your chart, you can look at multiplying how many options you have. So 2 options times 1 option means I'm going to have just 2 rows on there. That's the same for this one above. We had 2 options and 1 option. If you guys look at this one down here, we had 2 options. Sorry, we had 2 options and we had 2 options. 2 times 2 is 4, so we had 4 rows there. That's a way to tell how many rows. The other way to do it is just to make a chart, and then it doesn't matter how many rows that you have there. So in, positive, negative, imaginary, or complex. Okay. Our degree is 3. I could have 2 positive and 1 negative. How many imaginary? There would be 0 then. Okay, still a degree 3. I've already done 2 and 1, so my other option would be 0 positive. Still have to have 1 negative. That's the only option. So 0 and 1 and 2 would be my imaginaries. And there is no more left. There's our possibilities. Okay. Last one we have, again, if you're starting to feel comfortable with it, practice this one on your own. Okay, see if you can get it. My V positive, 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 negative, negative, positive, positive, negative, negative, positive, positive, positive. Okay, so my V positive is 4. So we're going to have more options here. I could have 4, 2, or 0 positive zeros. Okay, now remember, even exponents, we don't change. Odd exponents, we do change. So f of x equals x to the 6, even it stays the same. Odd, it changes. Even it stays the same. Odd, it changes. 4x cubed. Even it stays the same. Odd, it changes. And then we have the 2, which is not possible to change. Okay, count our variations for V negative. Positive, negative, 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 positive. Okay, so that would give us 2 variations. So I have 2 or 0 negative zeros. So again, how many rows are we going to have? We're going to have 6 rows because we got 3 possibilities and 2 possibilities. 3 times 2 gives me 6. You don't have to do that there. Some of you guys that like to be more organized might enjoy that. Okay. So we have a degree of 6 here. So let's start breaking it down. I could have 4 positive and 2 negative. 4 positive, 2 negative. If that's the case, I would have 0 imaginary. Other option, I could have 4 positive and no negatives. 4 positives, no negatives. Remember, that has a total up to give me 6. So 4 plus 0, I need 2 more for my imaginary. Okay, I've exhausted all the options for 4. I could have 4 and 2 or 4 and 0. Okay, now I move on down. I could have 2 and 2. 2 and 2, which would leave me with another 2 for my imaginary. 2 plus 2 plus 2 gives me 6. Okay, next one, I could still have 2, but I could have 0 negatives. So 2 and 0, which now would mean I would need to have 4 imaginaries to get that out of that. Okay, so now I've exhausted all of my options for 2. I could have 0 positive and 2 negative. 0 positive, 2 negative. Again, would mean I would need to have 4 to get myself up to 6. Okay, and then my last one here, we'll pick a pretty orange color here. I could have 0 and 0. So I could have 0 and 0. If I had 0 and 0, I would need to have 6 imaginary numbers to get myself totaled up. Okay, and that's how we make these charts for all the possibilities that we could have for how our zeros will work. Again, next time when we do this, the next time that we do this, we will be talking about which of those rows is actually correct. And we're going to revisit lecture 24 and talk about how what we learned that the imaginary numbers come in pairs is going to kind of change something that we did in lecture 24.